This is a demonstration of the actuator system designed for the automated window blinds. And as you can see, I have the same setup used in Project 2 Checkoff, which is just a simple pulley system with a piece of tape denoting the linear position. As you can see, I have that tape set around 0 currently on this meter stick. And this linear position will be driven by a DC motor, which is connected over here. And this DC motor will be controlled by an ESP and an H-bridge circuit. As you can see, it's wired directly to the H-bridge circuit, which is powered by this DC power supply from the wall outlet. And that H-bridge circuit is connected to my ESP, which is also powered by a wall outlet. And this ESP will be receiving commands from Node Red, which I will be sending from my laptop, which is located over here. And the first thing I want to go to is my calibration data that I had to take, since I'm doing this in a different setting with a different power supply. And the main thing I want to note is the standard deviation. So we know about how much deviation we're expecting to see at different values. And one thing you can note is that the standard deviation seems to be much smaller for shorter traveling distances and much larger for the longer traveling distances. So there'll probably have to be some sort of correction done with sensors. But for now, let's see how well it'll work. If I go over to my internet tab, you can see I have my Amazon Web Services and my Node Red open. A rather simple program with just a slider denoting what you want your desired position to be. And also, let me just show you in the GUI. We have our slider and then the text, which will show what your desired position is. So with that said, let's test probably two values, a shorter position and a longer position. So if I come in, let's say something maybe around here. So let's see, what does that say first? So 10 and pretty close to 10, about 9.5, 9.6-ish. So that's about what we expected. We expected rather good results at a shorter distance. Let me reset that back to 0. And then let's enter another value in here. Let's just see what happens. So let's do a much larger 34. Oh, that did pretty good. About 34.5. So it was fairly close, but I have seen it fluctuate more so. So there's several improvements that I think need to be made, such as adding sensors to give feedback in some sort of way. And a lot of that will be highlighted in the report. Thanks.